Hello, everyone. Welcome to the Analog Electronic Technology course. There are three basic configurations of bipolar junction transistor amplifier circuits: common emitter, common base, and common collector. What are the differences among them? In this lesson, we will compare them from three perspectives: configuration identification, performance comparison, and characteristics and applications. The three configurations of amplifier circuits are classified based on the positions of the input and output signals in the AC signal path. When the signal is input through the base and output from the collector, it is called common emitter amplifier circuit. When the signal is input through the base and output from the emitter, it is called common collector amplifier circuit. When the signal is input through the emitter and output from the collector, it is called common base amplifier circuit. In the common emitter configuration, the base current controls the collector current, with the emitter serving as the common terminal. In the common collector configuration, the base current controls the emitter current, with the collector as the common terminal. In the common base configuration, the emitter current controls the collector current, with the base serving as the common terminal. By combining the two-port network model of amplifier circuits with the small signal equivalent model of the bipolar junction transistor, we can derive the small signal equivalent circuit diagrams for the three configurations. From these equivalent circuit diagrams, we can quantitatively calculate and compare the amplification capability, input resistance, and output resistance of each configuration. The results are shown in Table 1. On the surface of the comparison results, the dynamic performance indicators of the three configurations differ significantly. For example, when comparing the input resistances of the common collector and common base configurations, both expressions contain the factor 1 plus beta, but the input resistance of the common collector configuration, Ri, is significantly larger, while that of the common base configuration is notably smaller. To enhance the persuasiveness of the comparison, we construct complete amplifier circuits with identical peripheral components, and again perform a visual comparison of the dynamic performance parameters of the three configurations. Based on the DC path shown in Figure 3a, we add the necessary coupling and bypass capacitors to complete the circuit construction for each configuration. Assuming the following component parameters: VCC equals 12 volts, beta equals 100, RBE equals 1 kiloohm, RB equals 300 kiloohms, RC equals RE equals 1 kiloohm, and neglecting the internal resistance of the signal source. Can you calculate the performance indicators of each configuration quantitatively? The calculation results for the three configurations are shown in Table 2. The above results are theoretical calculations. You can also build the actual circuits based on the DC path and perform measurements for intuitive understanding. Figure 4 shows a voltage divider bias DC path. Based on this, we can also construct amplifier circuits in all three configurations. Suppose VCC equals 12 volts, beta equals 100, RBE equals 1 kiloohm, RB1 equals 47 kiloohms, RB2 equals 22 kiloohms, RC equals RE equals 1 kiloohm, and the signal source internal resistance is negligible. The calculated performance indicators for each configuration are shown in Table 3. Comparing the results in Table 3 with those in Table 2, it is evident that due to the effect of the voltage divider bias, the input resistance of the common collector configuration is significantly reduced. This shows that the conclusion the common collector configuration has high input resistance is not unconditional. Bias circuits must be considered in practical applications. Based on the above performance indicator calculations for each configuration, we can summarize the characteristics of the three types of amplifier circuits. The common emitter amplifier circuit provides an inverting voltage gain. Its input resistance is moderate among the three, and the output resistance is closely related to the collector resistor. It is commonly used in the intermediate stages of multistage amplifiers to achieve both current and voltage amplification. The common collector amplifier circuit, also known as a voltage follower, has an output voltage that is in phase with and nearly equal to the input voltage. While it does not amplify voltage, it can amplify current. Among the three configurations, it typically has the highest input resistance, depending on the biasing conditions, and the lowest output resistance, making it suitable for input, output, or buffer stages of amplifier circuits due to its strong load driving capability. The common base amplifier circuit takes the emitter current, IE, as input, and the collector current, IC, as output. It does not provide current gain, only voltage gain. Its input resistance is low, and its output resistance is related to the collector resistor. Additionally, it exhibits good high-frequency characteristics and is often used in high-frequency amplifier circuits and constant current source circuits. In this lesson, we compared the characteristics of the three bipolar junction transistor amplifier configurations. The identification of the configuration should be based on the AC signal path rather than the DC path. By comparing the three configurations from multiple angles, we can objectively understand the characteristics of each configuration and the influence of bias circuits. In your future studies, avoid mechanical, one-sided, and isolated approaches to problem solving. Adopting an objective and correct scientific method will help cultivate innovative thinking.